Hi everybody, welcome back to part 2 where we're going to be running the study and looking at how to refine our mesh. So now that we have the mesh from the previous video, we can come up here and hit run the study. So it's not going to recreate the mesh, it's just going to run it now that we already have one. Let it do its thing. This can take anywhere from a few seconds to hours depending on really your mesh settings and what kind of conditions you have going on. So with a single part study, it's going to be pretty quick, just like it was. Alright. So there you go. You have all the pretty colors that you always see with FEA, and your part's nice and deformed. First things to think about, or I guess to tell you, are to ignore what it's showing unless it looks really wrong. So the deformation is way scaled up. So that's not actually how it's going to be bending, and you shouldn't pay much attention to that. In fact, you can come up here and uncheck deformed result, and that's usually a more meaningful, more professional way to show your results. So there you go. You have all your pretty colors. Over here, you have a scale. This is showing your von Mises stress. And there you go. You have your little arrow that shows what the yield strength of material is. So you can see the arrow is not showing up anywhere along the scale. If the part were to have failed under these loading conditions, you would see a little arrow pointing where it is. Okay. If you see that arrow anywhere on the scale, your results mean absolutely nothing. So it means the algorithm is unable to predict basically what's going on. So the algorithm is only good in the linear elastic region of the material. So when you see that it yielded, that means it kept going and trying to calculate past the elastic region. And if you know the stress strain curve, the properties don't stay the same. So your results mean nothing if it yielded. All right. Over here, you now have a results folder kind of spread out here. You have stress, displacement, and strain. Those are the three default options there. So stress is always going to show up first. Okay, let's go to displacement. Again, it shows the displaced deformed result. You can see right here the deformation scale 12.7. So that's scaled up a ton. Sometimes it's up in the 200s, 300s. So just go ahead and uncheck that. You can see right here it tells you a scale for what the deformation is. So it's in millimeters. And I'll show you how to format all this so it's easier to read later. But for now, we're just kind of looking at how to interpret your results. Strain, same deal. I don't use strain that much just because we don't use it too much in our analysis, I guess. We mostly look at stress, displacement, and then factor of safety, which I'll show you how to add later. So let's go back to stress. So if you want to know if your results are good, you basically need to show the mesh. So the quick way to do that is come over here to the scale, right click, and go to show mesh. Okay, so now you can see the mesh overlaid on the results. Now, what you want to look for is high gradients. Okay, so where the color changes rapidly. Each element, so again, I talked about that in the last video, one of these confined triangles should be relatively the same color. So right around here where the stress changes, you can see that this element here goes from yellow to red to orange, yellow, and this one's kind of a dark yellow, maybe orange, all the way up to green. So that is too much stress change for one element. Basically, the algorithm is guessing what's happening in here, and it's not going to be accurate. You see, your stress can actually shoot way up the more that you refine your mesh to make that more correct. Okay, again, over here, you have some crazy gradients going on. And so this result right here, I would not trust. If you bring this to design judging, if it's a good engineer, they'll laugh at you. So what you need to do here is you need to refine your mesh. So basically stop what you're doing, come back up to here, you go to mesh, and you could either create the mesh. Yes, it's going to delete your studies. Okay. You could create the mesh again and just bump up how fine it is. But if you saw on there, really the key points were on this fillet here and on the fillets right here. Okay. So a better way to do that then, let's get this here, is to add what's called a mesh control. So basically you can select a feature and pile more elements into that feature. So if we right click on here, you can say apply mesh control. All right. and then you pick which feature you want. So in this case, I'm doing this fillet. All right, and now you can drag the slider for only that element. So I'm going to bump it up to there, okay? And this is a ratio of like the element sides. 1.5 is a good default value. Don't make it too low, so it'll let you drag it down to 1, and that your simulation is going to go nuts. It's going to take forever. 1.3 is good. It just keeps it from stretching the elements out too long, which also leads to bad results. So I'm going to hit OK. And then you can see a little alert there because the mesh is no longer updated. You can see these little purple squares that show there's a mesh control on there. Alright, so let's just remesh that and see what happens. Create mesh. Okay. So just create it how you did before, but that mesh control is now on there, and so it's going to do a better job of putting elements on that fillet. Okay, there you go. You see it's a lot more fine in this area, which is what we wanted. Alright, I'll come back to these fillets here in a little bit, but for now we're just going to do that, and we're going to rerun the study. So you'll notice the study will take a little bit longer just because there's more elements. Sometimes if you hit more, you can see, so 143,000 degrees of freedom on this simulation. That's not a whole lot. You can see them up in the million when you get bigger. Alright, so now let's look at this stress point. And you can see the gradients are looking a lot better. So right up here, you know, we had a whole element going, you know, here, here, here. And now we have more packed in there. So this is all green, all green, all green. And this one, the gradient's a little bit, I would say, it's probably okay because it's not your highest stress region. Especially if you were close to failure at this point, I would refine it quite a bit. So sometimes, you know, you can have it zoomed out here and it'll just look like a black mess because there's so many elements piled into there. And that's okay. If your computer can take it, go ahead. One thing to note though is on sharp edges, so like right along here, if you apply a mesh control to that, or say like a chamfer, chamfers really screw up in SolidWorks simulation, and you apply more elements, it can actually lead to artificial stress concentrations. So just the way the algorithm works, it does not like sharp edges. Alright, so now that that one is looking pretty good, so it's a nice and smooth gradient here, I am more likely to trust these results. One thing you can do is you can add little flags if you right click on here. Let's see, if you go to edit definition, I'm going to play more with this. Oh, sorry, chart options here. I'm going to play more with this in the next video, but you can show the max flag there. Okay, and you can see, so actually the highest stress it thinks is over here at that point there. So now I'd say let's go ahead and throw some more elements on that. So it's going to be the same process. Mesh, apply mesh control, and let's just do these two right here. Alright, bring the ratio down to 1.3, and I'll make that a lot more fine. My computer's about to blow up on me here because I'm running a Mac with a virtual machine, but it's okay. So run the study. It's going to create the mesh for me with those controls, so I don't really care about creating it and then running it in this case. Let it take its sweet time. Alright, so the mesh is created. Now it's solving. You can see more nodes. And there we go. Now you can see there's a few more elements packed in here, and the stress gradient looks a lot smoother. So instead of big blocky triangles with the color changes a whole lot, we now have more accurate results. Okay? So now that you have this, I'm going to call it good for now. There might be some more tweaking to do if you were doing this as an actual simulation that you're going to base your entire design off. But in the case of this video, I'm going to call it good for now, and I'll move on. In the next video, I'll show you how to format this all nicely so you can have it easy to read, basically, and kind of export your results into design reports or whatever else you're using it for. So I'll see you in the next video.